Unit number 4, structural idealization, problem 1, problem 1. Okay, we have here part of the wing section is in the form of two cell box shown in figure. So this is the figure they have given. It's a two cell box, okay, in which vertical spars are connected to the wing skin to an angle section all through a cross sectional area of 300 meters square. So they have mentioned that this vertical spar, the vertical spar. So this is the vertical spar which is connected to the angle skin section. You can see this line 1313 is tapered. So that is what they have mentioned is the angled section, and each carrying a cross-sectional area of 300 square. So they have mentioned the cross-sectional area of the wing, which I am indicating. So I will change the color so that it will be easy to identify. So they mentioned the cross-sectional area. So here, so this is 300 meter square, say mm square, and this is 300 square, and this is 300 square, and this one is 300 square. So they have mentioned the cross-sectional area is at 300 square. Okay, the vertical ones are sparse. So they didn't talk anything about the vertical spar. Okay, only the cross-sectional area of the panels are 300 square. Okay, now we go to the question. Idealize the section into an arrangement of direct stress carrying booms and shear stress only carrying a panels suitable for resisting bending moment in a vertical plane. Position the booms at the spars and the skin junction. Okay, they asked us to idealize the section. So in such a way that the booms will carry a direct stress and panels will carry only a shear stress, and which has to resist the bending moment in a vertical plane. So now and then they ask to identify the booms. So based on the condition, we are going to idealize the section. Okay. So first, the figure A is a actual section, and figure B is a idealized one. So based on the condition they are given, we have idealized the section. So what they have given? So booms has to carry a direct load, and panels has to carry only a shear stress load, and booms has to be in the position in the junction of spars and skins. Okay, according to the condition, and we have idealized the section. So now we are going to determine the magnitude or value of booms, that is b1, b2, b3, and so and b6. So we are going to identify this value. Okay, so for that we already derived the empirical relation for booms, that is b1 equal to td thickness into the breadth divided by 6 into sigma 2 divided by sigma 1 plus 2. So we know this empirical relation we have derived in the last class. So we will use this empirical relation to identify the value of each booms. So now according to the figure, it is symmetric about x-axis. This section is symmetric about x-axis. So we have b1 equal to b6, b2 equal to b5, and b3 equal to b4 because of symmetric along x-axis. Okay. So from the symmetrical relation, and we know the value of t and b. So what about sigma 2 and sigma 1? So they didn't mention anything about sigma 2 and sigma 1, but they have given the condition that the section here, uh, they have mentioned the section has to be resist the bending stress, bending moment in vertical plane. So the direct stress in any point in the vertical plane will be directly equal to the distance between the centroid and the point. That is, if I want to identify a direct stress in the vertical plane, so this is a vertical plane. Okay, if I take any point, it will be, if I want to identify the direct stress is this point, so I want to identify sigma 1. So let's assume I want to identify at the sigma 1. Let it be clear. So if I want to identify a direct stress at this point, so it will be directly proportional to the distance between the centroid. So this length we consider as a sigma 1, and this length considered as a sigma 6, and this one is considered as sigma 2, and this one is considered as a sigma 5, and this is sigma 3, and this is sigma 4. So based on this, we will identify a sigma 1, sigma 2 up to sigma 6. So what is our sigma 1? So sigma 1 is the distance from the centroid to the point 1, boom 1. So sigma 1 will be, the total length will be 400. Total length will be 400 from 1 to 6. So from centroid it will be 200. Then sigma 6, it will be in the downward direction of from the centroid, so it will be minus 200. Okay, similarly sigma 2 equal to 150, sigma 5 will become minus 150, and sigma 3 equal to 100, and sigma 4 equal to minus 100. So now we know all the values of the parameters in the formula. Okay, now we will calculate the V1. So V1 is connected with the panel 1, 2 and the panel 1, 6. So we have to identify for both panel 1 and panel 1, 2 and panel 1, 6. So I will write the formula V1 equal to TD B divided by 6 into first panel 1 2 sigma 2 divided by sigma 1 plus 2 plus panel 1 6 TD into B divided by 6 into sigma 6. So I'm considering panel 1 6. So it will be sigma 6 divided by sigma 1 plus 2. So this is for a panel 1 and 2. And also in question they have mentioned this uh, the screen cross sectional area. So we have to consider the for panel 1 1 2, so we have to consider this a skin cross section area which also influence the bending moment of the section, so it will be plus 300. So not for the spot, only for the skin, so we are considering the skin is panel 1 2, so that's why we are using 300. Now we know all the values v1 equal to 2, and the breadth is a 600, p 600 divided by 6 into sigma 2 is a 150, sigma 1 is 200 plus 2. Similarly for panel 1 6, so thickness is 3 into breadth is 400 divided by 6, 100, and sigma 1 is 200 plus 2. Okay, plus we have 300. Okay, so when you solve this one, you will get b1 equal to 1050 mm square. So this is our b1. So b1 equal to b6. Similarly, b6 equal to 1050 mm square. Similarly, Now we go for a B2. A B2 is connected with the panel 1 2 and panel 2 3 and also panel 2 4 and process skin we have 1 2 and 2 3. So if it is 2 into 300, so I will write b1 b2 equal to, for panel 1, tdb divided by 2 into 1 2, right? We are considering a sigma 2, we're starting from a panel, sorry, boom 2, so it has to be sigma 2 has to be in the denominator and sigma 1 has to be in the numerator. So plus 2, then this for panel 1 2, panel 2 3 plus TD of the thickness of the section into B divided by 2 and then sigma 3 divided by sigma 2 plus 2. For panel 2 4, TD thickness of the section and breadth of the section divided by 2 into sigma 2 in the denominator and sigma 4 in the, a small mistake, it's not the panel 4, it is a panel 2 5, panel 2 5, so it will be sigma 5 divided by 2 plus 2. Now the cross sectional area of the skin, so we have two cross sectional areas of skin, panel 2 3 and panel 1 2, so it is 2 into 300. So now we will substitute all the value. So what is the thickness? Today's thickness is 2 into that is 600 divided by 2, sigma 1 is 200, sigma 2 is 150 plus 2 and panel 2 3, the TD will be 1.5 and B will be 600 divided by 6, sigma 3 will be 100, sigma 2 is 150 plus 2, okay, plus for the panel 2 5, so for spar 2 5, the thickness will be 2.5 into the width is 300 divided by 6 and sigma 5 will be minus 150, sigma 2 will be 150 plus 2, okay, plus the area 2 into 300, it will be 600. So when you solve this one, you will get B2 equal to 179, sorry, 791.7 mm square. So it is also equal to B4, sorry, B5. It's also equal to B5. The same manner we will do for a B3. B3 connects the panel 3 2 and 3 4. Panel 3 2 and 3 4. So B3 equal to thickness into breadth divided by 6 and denominator sigma 3 and numerator sigma 2 plus 2 plus thickness of the 3 4 panel and breadth of the 3 4 panel divided by 6 into sigma 4 divided by sigma 3 plus 2, okay, plus, so in the skin section we have 2 1 3, only 2 and 3 are the 2 3 panel is the skin section and 3 and 4 is the vertical membrane or vertical spar. So we have only one cross sectional area of the skin, that is 300. So now we substitute the values. So what is our thickness value? So it will be 1.5 1.5 into 600 divided by 6. Sigma 2 is 150, sigma 3 is 100 plus 2 plus for panel 3 4 for number for vertical spalt the thickness is 2 into 100, sorry, 2 into the depth is 200, that is 200 divided by 6 into sigma. Sigma 4 is minus 100, sigma 3 is 100 plus 2 plus 300. So if you resolve, you will get B3 equal to B4 equal to 891.7 meters. So these are the Boome's value or a Boome's concentrated area of each one.